To begin finding the volume of revolution of this solid about the y-axis, we need to draw the picture. Y equals x squared is this much. And I only drew the right side because we have the boundary x equals 0, which is the y-axis, and 2 minus x. So that's a line with a y-intercept of 2 and a slope of 1. So it starts here and goes down 1 over 1, down 1 over 1. That means my parabola doesn't look very much to scale. It should be starting at 0, then going to 1, 1, and doing this. So now we have this region to revolve around the y-axis this way. The question requests that we use the shell method. So we'll draw a line parallel to the axis of rotation that will help us visualize the shells that will be made like this on that other side, which once we made the rotation would go down and then be a parabola. So it's this funky thing with like a round bottom and a pointy top. So for the shells, the first thing we notice is that the thickness is happening in the x direction. We also notice that the radius of each shell is simply the x value. It goes from the axis to the x values, and those x values will go from 0, the origin, to the intersection of the two curves, 1. And then we have to identify the height. So the height of the shell will be the top function minus the bottom function. That's the distance from here, from this point to this point down here on the bottom curve. So the top curve is the line, 2 minus x, and the bottom curve is the curve, x squared, for the height. So for the shell method, the volume is 2 pi times the definite integral from a to b of the radius times the shell height with respect to your independent variable. In this case, we have x as thickness. That gives us 2 pi, definite integral from 0 to 1, a radius of x, and a height of 2 minus x squared with respect to x. From there, we just distribute, anti-differentiate, and evaluate.